So completing the Newton's second law problem solving. Definitely want to construct a free body diagram, and we got to show all of our work. So I'm going to kind of run through this. We just completed this problem. We're going to run through everything. First thing I would say to do, any forces that you can, draw in right away. So they said we have a rightward force, an applied force of 302, so I drew that in as my first step. Now, I've given mass and the coefficient of friction from the problem. Second step, guys, it should be, once you're given mass, you got to know this automatically. Find the weight, all right? Gravitational force in the object is mass times gravity. We're using 10 for g, so that's not going to be written down anywhere. You just need to know that. All right, we've been dealing with that quite a little bit, so if you use 9.8 for a different class, that would be what you would do. That gives us our weight down, so that would be my next step, which we just do draw that in. Your fourth step would be to know that normal force and weight equal one another. So since they equal one another, all right, no math is needed. You just know that now that's 286. Fifth step would be to draw it. All right, these guys are going to be equal. How do we know this? Well, if the object's resting on a surface, a flat surface here, or on the floor, our normal force and gravity here, our weight, are going to be equal to each other. Cool. So then what we had was basically we had this. Well, now we have normal force and coefficient of friction. So using, all right, our equations down here, we want an acceleration. We need net force divided by mass. The only way to get, all right, our net force was to figure out what the friction force is. Going to the left, well, friction force, FF, coefficient times normal force. So that is where we would have gone to next. Find the friction force. You have your equation, plug in your information, coefficient, which was given to us in the problem. Normal force, all right, is going to be the same as weight. So you have mass, you have weight. Weight, normal force equal. Normal force, all right, with coefficient gives us friction force. So once we figured that out, we draw that in. Now we're looking at our free body diagram. The top and bottom balance each other out. So to find the net force, now you're basically going to add or subtract however you need to in order to come up with a singular force. Top and bottom balance, 302 to the right, 214 to the left. So you're going to subtract them. Answer comes out to be 87.5 newtons to the right. So then to find your acceleration, here's your equation, net force divided by mass. Then you would plug in your numbers. All right, plug in the values that we had and get your answer, correct unit, all right, and then give the direction as well. If we took a look at let's take a look at number 2. During a football workout, 2 linemen are pushing the coach on a sled. The combined mass of the sled and the coach, 300 kilograms. All right, so cool, they give me mass, 300 kilograms. What else do they give me? They give me the coefficient of friction as 0.800. Remember, the coefficient of friction has no unit. And the only other thing that they give us is acceleration, 0.58 meters per second squared. Determine the applied force. So they want this. That is going to be our final thing, our final question mark. Okay, well, that's it. I mean, we don't have anything else necessarily right off the rip to figure out. But what can we do? Right off the bat, we can do 2 things. One, you're given mass, find weight. So 300 times 10 gives us 3,000 newtons. So then I would draw that in. Then got to know that normal force is going to be equal to the weight of the object. So that's also 3,000, and then I'm going to draw that in. Those two are going to be equal. Why? Because they're pushing the coach on a sled. They're not accelerating it, lifting it upward, or pushing it downward. Right? We're assuming completely horizontal unless you're given an angle in a problem, in which case you would have to do the cosine in order to figure out, all right, what the actual applied force there would be. Now, okay, that would be my step 4. All right, take mass times gravity, you get weight. Weight and normal force are equal. Draw them in. Cool. Anything else I can do right off the bat? Well, there was actually something I could have done earlier, but I waited, so we'll sit on that for a second. Hold on. Can I find friction force by chance? And another question was, how do I know friction force is to the left and applied force is to the right? Unless they tell you different, that's how we're always going to draw our problems. All right. Always, we're going to send the applied force to the right, friction force to the left, unless told otherwise. So can I find friction? Unless I solve for F net, I can't find friction? Yeah, we can. Why? Because look what we have. All right. What is the equation for friction? All right. Yep. So the triangle down at the bottom. Friction force is coefficient times normal force. You have now coefficient that was given, and we just solved for, right? We solved for the weight. Weight and normal force are the same, so that's 3,000. So normal force is 3,000. Coefficient is this. So we can now solve for the friction force. Taking 0.800 times 3,000. And this gives us a friction force of 2,400. Next step, draw that sucker in. Okay, now, Mr. Lombardo, I was kind of with you up until here. Now I'm stuck. Well, I don't know what to do from here. Does anyone have an idea of what they would want to potentially do? We'll look down at your triangles. All right, look down at our triangles. And let's ask ourselves, do we have any equation left and our given pieces of information that we can find something else? Right, so let's see, what do we have? We have weight, normal force, friction force, mass, coefficient, acceleration. So we had this and this. All right, we don't need to worry about G, so no, we're not going to use the rest of this equation. We just found normal force, and we had this and this, so we're not going to use here. Well, let's see, what else do we have? We have mass and acceleration. So what can we find now? The net force. So that would be our next step. God bless you. And the triangle says we're going to take mass times acceleration. Let me zoom in now. Mass of 300 times the acceleration of 0.58 gives us a net force of 174 newtons. Now, it doesn't quite say direction-wise here, but we're assuming that the applied force is greater than friction, all right, and that they're accelerating them to the right because that's how we're drawing our our applied forces. Okay, so what would this mean? What would my free body diagram look like if I just said, all right, hey, you have a net force of 174 newtons to the right? Well, that would then eventually just kind of summarize down to this. It would be 174 newtons to the right. So that means, so now the importance of the drawing is if the net force is in the same direction as the acceleration, okay, again, we're assuming to the right. That means that the applied force needed to be 174 larger than the friction force. So for, well, this would be, I guess, step 8. All right, so to find this applied force here, you would need to take the friction force and the net force, add them together, because this side has to be greater than this. So we were just taking our 2400 plus 174, and you're going to get 2,574 newtons. That would be what my applied force is, and then I would just ask that you draw that in. And that would be your little 9th step there. Okay, so in fast mode, the only things they gave us, mass, coefficient, acceleration. Now, I could have found net force first right off the rip. I could have done that because I have that equation. All right. Now, that wouldn't help me right off the bat with the drawing. I would just need to know that, all right, assuming that we're going to the right, the net force would be going to the right. So that would just help me in the end with the drawing, knowing that the applied force has to be greater than friction. But my first step was, or one of the quickest ones that I can find, if I have mass, I know gravity, it's given, all right, it's a constant, all right, -10, or we're just going to use 10 because we don't care for the negatives at this point. You get 3,000 newtons. Then you draw that down, all right? So mass times gravity gives us weight, Fg, we write that down. Okay, you need to know this fact, this will be your third fact, that normal force is going to equal our weight. So that is 3,000, then draw that in. So those two are equal to each other. That's why we're giving them this little equal symbol. Now that I have normal force and I have the coefficient of friction, I can solve for the friction force using the friction equation. Is friction force equal to the coefficient times the normal force. So I take the 0.800 that I'm given, times it by my normal force, and I get the friction force. That was my 5th step, and then the 6th step would be I just drew that in. Okay, 6th step, just drew that in. Number 6. Okay, now from there, what I did next was find what the net force is. I took my acceleration times the mass given, found out that I have a net force of 174 to the right. So we're assuming it's to the right because unless told otherwise, that's your applied force is always going to be to the right. And it says that it's accelerating, it's not slowing down, so friction force would not be greater in this case. So I just drew this little piece here that helps me realize visually that the right side, the applied force has to be 174 newtons greater than the friction force. So that's all I did then for the applied force is I added the two together, got this guy here as my applied force, and then I drew it in as my final step. All right, so that would be the speeded up version of that. Now, number 3. All right, well, let's see. What do we have? We have a 405 Newton rightward force being used to drag a large box across the floor with a constant velocity of such and such. Okay, so let me ask, guys. There are 2 pieces of important information in the first sentence. Does anyone know what those 2 pieces are? Very good. 405 newtons to the right. What else is important? All right, so that's something that everyone messes up. So I'm glad you said that again, because you're given a number. You're like, all right, I have to use it. Well, look at our equations down here. Do any of our equations have velocity in there? So we're not really concerned with velocity at this point. It's going to be balanced. Why? Because right here. All right, and I even wrote it down at the bottom for today. Constant velocity means the net force is going to be 0. So those are the 2 super important pieces of information. So the first thing I would then wind up doing is I would draw in my applied force to the right. And now realizing that I have something as moving at a constant velocity, that means the net force has to be 0. So everything has to balance. So if I have 405 newtons to the right, how much do I need to have going to the left? 405 newtons. So no math was even done there. All right, but rightward force, constant velocity. Constant velocity is basically like your second step. It's going to tell you that, like, all right, everything kind of needs to balance out. Cool. So then what else are we left with? We're left with coefficient of friction is 0.795, and they want mass. What is the equation for mass? Okay, well, I have mass in 2 equations. I have one here and one here.
So it's Fg over gravity.
Fg over g?
Yeah, it's the it.
All right, well, can I use this one? I can't use this one right now because I don't have Fg. Dang. Okay, so I'm in a pickle. And I can't use this one because I don't have acceleration or net force. So, Mr. Lombardo, I am now officially stuck. Okay, that is all right. But what you have to look at, guys, and figure out.
But you technically do have F net. It's constant velocity F.
Okay, true. But think about it. If we said the net force was 0, divided by any acceleration, the mass would be 0. Any object, it's got to have some form of mass. Okay, so not a bad. I'm actually glad you said that. Why can't I just do this? And well, think about it, guys. A large box. Do you think any large box or small box, for that matter, is going to have a mass of 0? All right, so that you got to use your brains. All right, common sense a little bit. Okay, so wait, I can't use that. So I'm going to have to use this. So how the hell can I get Fg? G is always 10 because that's gravity. So what do I do? Well, look what I have right here. You see this? Weight and normal force are equal to each other, right? Okay. So I need this because I know that G is 10. So I need weight. I can't do mass times gravity to get this because I don't have mass. But do I have enough information to find the normal force?
I think so.
Well, Fn is equal to, yes, Fg, but we don't have that yet, so we can't say they're both equal to nothing. We just figured out the friction force because
405 divided by 0.7.
Very good. Okay, so you're given coefficient, and we basically figured friction force has got to be this because everything had to have been balanced. So then what you're going to do here, friction force divided by the coefficient. So 405 divided by 0.795, and that's going to give us a value here of 905.43 newtons. Now that is my normal force going up. Okay, now what? If that was my third step, fourth step, draw it in. Again, constant velocity means everything has to be balanced, correct? Constant velocity means F net has to be 0. So I guess this would be step 5. These two are equal. So if I know net force, I know weight, or F sub g. So that's also going to be this 509.43, and I want to draw that in. Cool, everyone's balanced out. And now I can find the mass here. Okay, so now I can find M. This will be the 7th step. M will equal, all right, gravitational force over gravity itself. So we're using 10. So you're going to take this 509.43 divided by 10 and get a mass of 50.943 kilograms. I calculated that earlier. Well, slash, you're dividing it by 10. So you just move the decimal over to the left one. All right, and this would be your 8th and 9th thing. Get the correct number and the correct unit.